So we looked a moment ago. We saw that different different frequency light, we see different colors. And I said, and so we can see here, we can actually when you shine light through a prism, then it bends differently depending on what the frequency of the light is. In fact, you can shine white light, which is a mixture of all the different colors, and it will separate out the white light into the different frequencies for you, which is quite useful. That's what prisms are often used for. So let's have a look at this again. We can have a look. We see the waves are slightly further apart. And if we look all the way down onto blue, we can see they're slightly close together. And I said that there's a range of which we can see the different wavelengths. Or the different frequencies. So this range here, this is around about 400 nanometer. Now, a nanometer is equal to 10 to the minus 9 meters, or in other words, 0.1, 2, 3, 4, 5, 6, 7, 8, 9. So 0. All that. That's how many. That's how tiny that a nanometer is. So we can't here measure anything. We can't detect anything with our eyes with a longer wavelength than that. So this is longer wavelength. Longer wavelength, or we could say also lower frequency. And this is shorter wavelength. And it's also higher frequency. And the highest frequency that we can detect is around about 700. Sorry, the highest. Hang on, I've got this the wrong way around, haven't I? Yes, I have. So hang on a second. Let me just get those the other way around because it's a longer wavelength at the top. I'm just going to get my eraser. I'll just pause the video to correct that. Try that again. See, that must be right then. So the red's got the longest wavelength, so that must be the 700 nanometers. And then blue-violet has got the shortest wavelength, so that must be the 400 nanometers. You don't need to remember these numbers, but just for your own interest. And also the thing that so basically, if I were to actually go longer than that, so if I were to move this down, the waves are still there. We just can't see them anymore. So ultraviolet is emitted from the sun. If you go down even further, well, it doesn't have all of them, in fact, but there are. So basically, it goes radio waves, then it will have something called microwaves, then infrared, then this will be called visible light, then ultraviolet, then you'll have X-rays, and then gamma rays. Okay, you can look up that to see the series of the order of the different waves anywhere online. As you go from the top to the bottom, also what happens is the energy of the wave increases. Okay, so the energy increases. So radio waves don't have much energy. Gamma rays down at the bottom here, they have loads of energy. Okay, I'll just actually might as well finish this thing here. Visible, and then it's I missed one out. X-rays. Okay, yeah. And this one is microwaves. Sometimes microwaves aren't included. Sometimes they're classified as a type of radio wave. But in GCSE, you'll learn radio waves, microwaves, infrared, visible, ultraviolet, X-rays, gamma rays. This topic is linked to the Doppler effect, which we will return to when we learn about space physics. Okay, but we're not going to do that right now. Okay, so let's stop that there.